CloudEvents and XRegistry, and this is what we're going to talk about today. So my name is Manuel Ottlik. I'm a product owner for cloud native platforms at HDI Global. That's an insurance company in northern Germany. And I want to talk about CloudEvents and XRegistry. So maintainer track, always a little tricky one because you have a few people that have not heard of these projects ever before and want to get to know them, as well as some veterans that know exactly what's going on and basically need the nitty-gritty details of what changed. So I will try to make both of you happy. We will have an intro and explanation on CloudEvents as well as XRegistry. XRegistry, a more deeper explanation since this is the newer project, fairly unknown probably. And I will try to make this more understandable with a demo. So we're going to use a to-do list example, and then I'm going to use the last 5 minutes to explain why an end-user company might be interested. And finally, I will share the project roadmap with you, which a few people have been asking last year already, and we have one to give in this talk. Starting with CloudEvents, I will assume most of you have heard of CloudEvents already. It started in 2018, is graduated since last year, shortly before KubeCon, I think, and it defines common metadata for events. So there are many different messaging and eventing protocols out there, and even more event brokers. And they have quite a few things in common, but often differ in detail. And it's a little bit like if you were to send a letter to a friend, but depending on which postal service you use, you have to write different things on the envelope. So this is where CloudEvents comes in. It is defining these common metadata, and it defines protocol and broker independent headers. So what we are not doing is we are not telling you how to write your letter. This is about what you write on the envelope. So it's not about a common event format, but about common event data. And we have 9 SDKs to do that, 6 protocol bindings, and this is what it actually looks like. So I just told you we're not telling you how to write your letter. This is the envelope. This is an AMQP protocol binding. We have a few more, 6 in total. We have Kafka as well. We have HTTP, MQTT. And you can see all the common metadata up there. And this is your letter. This is the one that you would be writing. Now, the nice thing when using this binary mode is that you do not have to do a breaking change, so you don't have to break your schema contract with your existing consumers. You can start using CloudEvents without actually breaking that. If you don't want to do that, or if you cannot do that, you can also use the structured modes. That's the second option we allow, where you don't use the protocol headers, but instead you actually do use the payload, and the very top level uses these attributes and puts them in there, and then your letter, your payload, lands in the data section. So what I just showed you has existed for a few years now, and it's very stable. I mean, it's a graduated project. That's kind of what you expect from it. And what is still changing and where there is still a lot of involvement is the extensions for this project. And one would be CESQL, Cloud Events Structured Query Language. And that is 1.0 now. So what you can now do is you can query for the event metadata and basically filter down on your events. And Knative is already using that. They have a filter expression in place. So you can put the CESQL expression in there, and then only the events where this expression evaluates to true will end up in your service or end up at your consumer. We also have 4 new extensions that have been released in the last year. The first one being BAM, that stands for Business Activity Monitoring. I had to look that up as well. And it monitors the progress of a business process and defines headers needed for that. We also have data classification that might be interesting for everyone from Europe, where we have the data classification one that talks about the confidentiality of the data, as well as the data regulation that could be GDPR, and the data category, which could be sensitive or not sensitive. And the last one, or not the last one before, but interesting for all continents is deprecation. It answers 4 questions. Is your event type deprecated? Since when is it deprecated? How long will it still be supported? And what can I do to migrate from this event type to the one that comes after that? And now the last one, OPC UA, unknown to a few as well, I guess. that is an industrial protocol, and the extension itself provides a mapping from these protocol to CloudEvents headers and adds a few as well. So that is what happened in the CloudEvents spec. We are now moving over to XRegistry. And when CloudEvents managed the interoperability of the metadata for events, it still leaves many questions unanswered. And for that, we're going back to this metaphor of letters and envelopes, because what would be nice to know in our event-driven ecosystem is what event types, what letters, what envelopes actually exist. And since I just talked about the metadata that can be on there, it would be nice to know, okay, what metadata, what event type has what kind of metadata, uses which kind of extensions. Also, it's interesting what the actual letter inside looks like. So knowing what the payload is something you would like to know. And then the last thing, that's where I put the nice DHL postbox in there. Where are the postboxes? So where can I put my letters? Where can I send them? Where can I receive them from? Basically, in distributed systems, where are the endpoints that I have deployed to send and receive messages? So these questions came up in the CNCF serverless working group that has created CloudEvents first and then moved over to answer these questions. And we came up with something that we called CloudEvents Discovery. And it has these three entities here. So first is the message definitions. Those are our envelopes, the event types. They have a definition and they can be versioned because events change over time. And they are related to the schemas. That is our actual letter, the payload of an event. And we have schema groups, we have the schemas itself and the versions of those schemas because they as well do evolve. And the last thing we defined would be endpoints, where you could register your post boxes basically. So we created that and we were kind of happy because this is like the most important thing you need. And then realized, well, they all follow the same pattern. And we do not want 3 specs, but we would like 1 core spec that takes care of all this stuff, and we would like to have 1 interoperable API. And for registries in general, that would be a nice thing. It would be nice if we would have 1 core spec that could be extended to these different entities. And that's when we decided to not call it CloudEvents Discovery, but call it XRegistry. So XRegistry itself is XRegistry standing for Extensible Registry. XRegistry itself and its core specification does not have anything to do with event-driven architecture, eventing or anything. It is just an abstract concept to manage metadata about resources. Any metadata about any resources. And it has this very easy model of groups that have resources, and those resources can be versioned. And I will show you later in the demo what that could be, because this is kind of abstract. So the endpoints, messages, and schemas that I just showed you are just implementations of that core spec. So if I just slide that model from the slide before in, you can see that the schema groups are on the groups level, the schemas are on the resource level, and the schema versions are on the version level. So what we have actually created, or what we aim to create, is a vendor-agnostic registry specification that can be adopted by any other vendor as well without breaking their business model. So the main value proposition of this project is this core specification, because it provides the interoperability and lets you define basically any resource managing any registry managing any resource. The endpoints, messages, and schemas are then just implementations to that spec. What we also have is a server implementation, a reference implementation. We will take a look at that as well. It's written by Doug Davis and is part of the XRegistry group now as well. And we will have a CLI as well that's written by Clemens Vastas. It's not in the group yet, in the GitHub organization, but will be soon. So depending on your persona, you might value this core specification, you might value these endpoints, messages, schemas, implementations of that core specification to get started, or you might want to have the CLI or the server. Going from this like abstract layer down to a very concrete example. We have a to-do list service by an example corporation. And on that to-do list, we have 2 tasks already. You want to attend KubeCon 2025? You are here. That is a success. You want to attend the XRegistry talk? We have done that as well. Now we want to add a new task, and that is drink beer at KubeCrawl. I learned it's called KubeCrawl. We'll name it KubeCrawl. You can do that in a few minutes' time, but just creating that task created an event in the background as well. So we have a cloud event. It's the same cloud event I showed you before, where you have your metadata up top, the envelope, and you have your letter in the bottom where you can see the label is drink beer at KubeCrawl, and it's not completed yet. Now let's imagine, let's jump 2 hours in the future. We will tick off that task, and now you can see I can jump back and forth. We have a new event. It's task.completed, and it says completed finally. This is my very, very complex application. Now we want to take a look at the even more complex architecture. We have a to-do list service on the right, on the left. Then an event broker where these events are emitted to, and a consumer that could consume that. And what we have up top is a registry that is implementing the XRegistry specification. So this could be DAX reference implementation or any other registry that decides to implement that specification and comply with it. Now, the very first thing the to-do list service would do is it would create these entities, so the envelope, the schema, the message, and the endpoint. And then it can just provide these cloud events, send it to the endpoint. In this case, it's nuts, doesn't really matter. Will be nuts in my demo as well, so that's why it shows that. And then any consumer could go to the XRegistry or a catalog that is built upon that and get this information. And then consume the cloud events or whatever events basically from the endpoint. I do want to show that to you now, so I will end the presentation short and start with VS Code, where we have a registry. You can see that, right? Is it big enough? Yep. Okay. Where we have these three main things. So what we see here is just a JSON file. And in its very simplest form, an XRegistry can be a JSON file. So we have endpoints up here, and I will unfold that. And you can see it has the name example.com nuts, reversed with reverse DNS notation. And in this case, it's a producer. The envelope is CloudEvents 1.0 because you could register other envelopes here, and it will use the protocol of nuts. Yeah. For your protocol, you then have protocol options that you can define. In this case, it would be a URI for nuts to connect to, and you can make some statements about the subject structure for nuts. You could use HTTP here, and things would look a little different, but this is how you would define an endpoint, a nuts endpoint. We then have message groups, where the first thing we have is our group. And in this case, I grouped it by the service. Example.com has a to-do list. And inside this group, you have many messages. For example, task.created, and if I fold that, you will see task.completed. Here you will have a statement about the envelope again and the data schema format as well as the data schema URI. So this is, we are talking about the envelope. This is referencing the schema, so the letter, in this case would be JSON schema, and you can see there is a reference to schema groups, which we will look at in a second. Now the most important thing is that most of the information actually lives inside the version, because this is all stuff that gets versioned and can change over time. So we will have the envelope and the envelope metadata again. And this is where it gets kind of interesting, because you can narrow down on the cloud events attributes and say, for example, that this kind of event has a spec version of 1.0 for cloud events. And you could even set the type. This is just like a concrete value. This will not change. So you know what type to expect, as well as the value for the source to expect. You then have the data content type, data schema format, and data schema URI again, in this case pointing not only to the major version, but the very exact version. Let's now look at that and close this and open schema groups, where you have the same structure again, because you do have a group again. It's called com.example.to-do list, basically the same. And now you have schemas that can be versioned again. And in this, you have the schema itself. So I said earlier, it's JSON schema. So under here, you just have a JSON schema object that makes a statement about that there is an ID, a title, and a completed field. This is what an XRegistry can look like in its simplest form. Now, what I want to do now is I will copy this curl request I have up here, and we'll paste that in here. And we will put this into the REST API version of this exact registry. So what we are looking at now is the UI that Doug created for his server implementation. I will plug that right here, XRegistry/server. You can also look at XRegistry/spec. And for that server, we now have all the information that was in my JSON file into the registry already. Now you can see we have endpoints, we have message groups, we have schema groups. And we could take a look at the endpoints, and you can see com.example.nuts, and you will see a few additional attributes. You now have a self URL, you have an XID. An XID is basically the last part of the URL of the REST API. You will have things like an epoch, created at, modified at, and you will have all these URLs that allow you to jump to different places. Let's go back here and go into the message groups, where you can then also see, if looking at messages, you can see the created one. And what you see now, if you compare this to the file version, is that you have many more attributes in here than there were in the file. This is because the default version is per default integrated into this very message. So by default, you always get the most up-to-date version when you query the resource. What you can do, though, is you can take a look at all the versions there are. I was lazy. There's only one version. So in this case, this is the default version. If there were two, let's say I have 1.0.1, then this one would not be default anymore, and the 1.0.1 would be part of the resource itself. So let me check if I forgot to explain something. OK. What I now want to do is I want to show you the actual model that powers this registry. I told you earlier that you can describe any metadata. So there's actually a model, kind of a meta model, that says how this registry is supposed to look. And it says you need endpoints, you need message group, you need schema groups. You can look in here and see, OK, a group can have resources, and those are schemas, and those can be versioned. I told you earlier. Now, to prove that you can do anything with it, we have a few other registries in here. And when I look at these models, you can see now we have groups in this APIs guru that Doug has built, where you have API providers. And inside API providers, you have APIs. And those will have different attributes. You can look at these as well. And we have one for doc store as well, where when you look at this model and you look at the groups and the documents, you can see, well, you look at the groups, and the groups are called, there's a group called documents, and it has resources inside them that is called formats, and those have different attributes as well. So you can create your own model here and basically build, I said it 3 times already, any resource, manage any metadata about any resource. Now, what you can also do is you can take that stuff from the registry and put it back into a file. To do that, let's go to the root first, and we will do something that is kind of basic for REST APIs. We will inline everything we have, and then we will use this fancy unfold button, and you can see what we have now kind of looks like the JSON file that I showed you in the very beginning. The difference being that you now have stuff like self, XID, epoch in there that is added by the server by default. And what you can then do, you can add the doc view to actually make this a document, and you will see that a few of those actually get removed again. So in this case, if we look at not endpoints, but message groups, you can see that you have less information on the message level because that would just be redundant and not update nicely. And we even have a shorthand for that that is called export, where you can just take that file and use it locally again. So jumping back to that demo, This is something that is kind of important to us, which is the symmetry between these representations. So you can start out with a single file and then go to REST API and go back if you want to. Now, there's a third representation that we also enable you to use, which is a static file server, where you could just mimic the structure of the REST API by splitting your registry up in several single files, put them in any static file server you like, and then they will be usable as a read-only registry, of course, by your customers. There might be a use case if you're like a platform engineering team and your people get a GitOps repository where they can just define their schemas, and you take these schemas, have a pipeline, and compose that up to a static file server. What you can now also do is you can use the CloudEvents data schema field to reference to the XRegistry. If you used that in the past, those go nicely together. But what I want to focus for the last minutes is the end user view. So why is this interesting for an end user company? Why is this interesting for you, in case you are one? So looking at HDI, we have about 300 developers working in agile software development teams, and all of them have to build, maintain, and manage interfaces. So what we decided to do is we decided to create a platform for that. And as a platform team, we are providing them with infrastructure, tooling, guide rails, and enablement. And this platform, we call it very creatively Global Integration Platform. And it has 3 components to it, which is an API management, a message bus, and an event broker. So if we are looking at that, we have our customer. He's on the left. And these customers, these developers, are usually developing business services. And business services usually deal with business objects and business events. And they then set them free via interfaces. Those are the nice plugs I put in here. And if we are looking at the global integration platform, having the API management, the message bus, and the event broker, we offer them they actually live there. This is where the interfaces are living. And we offer them different ways to describe these interfaces. If we're looking at OpenAPI, this is how we do it in API management. So you're describing your interface, but at the same time, by describing your interface, you're also describing the business object that you're pushing over there. For the message bus, we are offering them to build a JSON schema, to write a JSON schema that describes the message, that has some information about the message in it, but at the same time, there's a lot of information about either the business object or the business event that goes over it. And for the event broker, there actually is a registry in there that can do ever and JSON schema. But again, we are repeating schemas. So if a business service is using all of these products, the probability that he is repeating schemas is quite high. And even worse, there might be the probability that these business events and business objects actually look quite distinct from each other. So they might have a different version cycle, different versioning, different version numbers. And that just makes it a little more cumbersome to use. So what we would like to do is we would like to have one single place in the center. This is something we want to change. We would like to put all these definitions in one place and connect them with each other. And this is what XRegistry can actually do. We can put all the JSON schema in there, all the Avro in there, and then to just define the interfaces using OpenAPI or using async API in these separate products, because this is what actually is distinct when using these products, and reference everything that has to do with a business object or has to do with a business event to XRegistry. So basically, what we do want to do is we want to store the metadata independent of the integration product. And we want to avoid the repetition of schemas, and we want to harmonize the schemas across integration products. But even further, we might want to do that looking at data products in our BI platform that use similar schemas as well. And we also want to connect this metadata. They now live completely separate from each other, and this is something we can change by using this extensible concept. So looking at the outlook, the roadmap. What we have done already in April 2023, almost exactly 2 years ago, is when we created the spec repo that I showed you. This is where it moved out of the CloudEvents organization into its own organization. We set up this initial repository, we had some governance, and migrated all that stuff. And what we did last month is we filed for a sandbox application for CNCF. That has the core spec in it. It has the endpoints, messages, and schema spec in it, as well as the reference implementation. What we did just yesterday is we had a release candidate 1 that you can all look at. This has all the relevant core spec in it. It is ready for implementation testing, ready for reviewing. And what we want to do in 2 months is have a RC2, and then another 2 months to give everyone the time to review is the version of release 1.0. So, taking away from this talk, I think it's very important for CloudEvents, check out CESQL, check out the 4 new extensions that are out there, especially deprecation, I think, would be interesting for everyone. And for XRegistry, you can review this RC1 right now. The QR code is on the right. You could use the core spec to build your own registry, or you could use the messages, schema, and endpoint implementation specs to describe your event-driven architecture. And what you can also do is you can run the server locally, the reference implementation, to play around with a registry like that in action. So, thank you very much. There is a question over there.
A fairly obvious question about CloudEvents.
Yes.
Two of them. What would you say is the primary use case for CloudEvents? And secondly, if you stacked ranked a list of use cases in your head, where would tracing come?
Stack ranked?
So if you had an ordered list of use cases for CloudEvents, where in that list would tracing fall?
Tracing is an extension in CloudEvents already. So what is already available for, I don't know how many years, is basically, I think it's called trace state and trace parent. Those are the 2 extensions. So you can just put your trace in there and have it propagated from one application to another. Primary use case is probably harmonizing that metadata. What we see at HDI is that people use either the same header with different meaning, or they use a different header, but they have the same meaning. So this is really what we try to get rid of, to have this like common understanding of what is an event type, what do I put in there.
Thank you very much for the work on this project. My question is, how do I get my OpenAPI spec or async API spec into the XRegistry server as of today?
What you can do already is you can put in, for the schemas, you can put any schema in there. So you can put Avro, JSON schema, protobuf. You could do OpenAPI, async API as well.
So I can write it plain to the server and then it translates it into the structure?
I didn't understand, sorry.
No, if I have an OpenAPI YAML or async API YAML file, how do I get that?
We do not care what document you put in there as a schema.
Yeah.
So you can. So what we have is the metadata for that schema, which is in the form I showed you, and then you can just append any kind of file you want. That could be an OpenAPI YAML.
Okay.
Did I answer the question? Kind of. You can come up later. All right. If that's it, you can rate this talk if you want to, or you can go and tick off the last item of the to-do list.